Hello, hello, hello. Are we working? I really need to get a monitor over here so I'm not looking that way the whole time, where my streaming setup is. JFix, hello. Hello. Hello, everyone. You're the only one here, JFix. I'm sorry. You're the only one here. Oh, there's Andy. Andy quit streaming for the day. Hello, hello. Hello, hello. Is this updating? Cheers, everyone. I'm trying a little different setup. Yeah, I need a monitor here, though. I really do need to, I don't know, work on that. I do have some power supplies to work on. Someone named Chip sent me some supplies. He posted in Discord when anybody, did anything with these supplies, and a lot of you tagged me in it, so I appreciate that. So we're going to be taking a look at some of those supplies. I have not even opened the box yet. So we'll do that for a while. Well, thank you, JFix. This is not. I'm looking at a window off. My streaming window is not. It's not updating as far as like concurrent viewers and that kind of stuff. It's just kind of sitting there. What happens if I hit refresh? Does it all fall apart? Okay, that's better. This camera is just a cheap USB webcam. And I have fought in the past getting two of these USB webcams to work at the same time. And for some reason, today it decided to work. So I need to get a better camera. It's not a very good camera. I mean, it's better than nothing, but it is a cheap Logitech USB webcam. And there's another, off-brand webcam over here pointing at my DC load and that kind of stuff. So we're a very low-budget operation here, as you can tell. There's Russ. Thank you, Russ. Russ is one of the founding members. Yeah, I have a face cam. I may do away with it. We'll see how it goes. I don't really trust this thing. I need a better camera. I need better cameras all the way around. But we're a low-budget production. So let's get this box over here somewhere. And I have some sad news for you. I was trying to do a video this morning. Preparing a PS5. It's over here running. And the audio did not come out. The stuff that I recorded in OBS, like some of my recording I do straight to my phone. I take my wireless mic receiver, plug it into the phone, all that's fine. But anything I recorded in OBS is just choppy, choppy, chop, chop, chop. It's, hello. It's unusable. And I was so frustrated this morning. I thought I'll get a video out and then I'll do some live streaming. Life will be good. And no, I've tried to edit around it, and it's just not usable. It just sounds like a robot. So yeah, sad news. It was a shorted capacitor on the SSD, DC-DC converter, and a blown fuse. Nothing too exciting, I guess. But still, I wanted to put out a video. I don't know what all I have been sent here. A box of goodness here. We have 6 power supplies and a He said he was going to send me one of these PS5 repair kits. I guess they sell on eBay. Said it may be missing some items. I'm curious what's in these things. I'm guessing the MOSFETs, maybe a TEA chip. So we have 6 supplies, and these look to be original OEMs and not the cheaper knockoffs. DR, 400 DR, 400 DR, 400 DR. Got to get some off the bench. 400 FR, DR, and an FR. So four DRs and 2 FRs. Welcome, if you're just getting in here. Well, thank you, JFix. And yeah, Draco80, thank you for joining, becoming a member. Thank you. Yes, all these are from, I think his name is Chip. Yes, these are all from Chip. They arrived, I think it was yesterday. What is in this kit? I've seen these advertised on eBay. Huh. I know what that is. I think, no, this is an X2 capacitor. I'm sorry, I thought this was the one in the LLC. That's interesting. I haven't had one of these fail. This is across the, I don't have a supply open to show you. This is an CX1 and CX2. This is going to be basically across the AC line, part of the filtering. You know, basically to keep the hash that the power supply produces from going back and out and radiating down the power line. And we've got a couple of chips in here. I've never seen one of these. How is that stuck in there? Okay, let's see what this is. I can't tell. Okay. I included a microscope view on this, didn't I? Oh, it's a DAP053. Is that showing up? I thought they'd include the TEA chip. Okay. At least it's marked. And this other one, what is this other one here? DAS01B. Okay. And we have some MOSFETs. I'm going to guess the PFC MOSFET, and then a couple for the 12-volt DC-DC converter. Q3, Q4, Q6, yeah. I don't think these are the original parts, though. Interesting. And there's a board, a little circuit board here. Looks like a steady-state high-voltage starting board. I'm not sure what the heck this is. It's got an opto-isolator on it. A couple of resistors, a jumper. Steady-state high-voltage starting board. I don't know what this does, or why you would need it. Anybody ever used one of these little eBay modules? Knows what this thing does? Oh, should I change the scene? Well, I've got a microscope view in the corner. Yeah, the membership thing is something I added, well, kind of quietly recently. Wasn't making a big deal of it. I don't know what that does. But this is something I chipped through this in. A couple of capacitors, and whatever was in here has been removed. I don't know what that was. He said something, there may have been some parts missing. Anyway, it says for the DR and the ER. Output voltage test digital display meter. Oh, that's what those two prongs are for. So it's some kind of a little meter. Yeah, you can see the spacing for the prongs. I'm sure we could find this thing on eBay. It was some kind of a little voltage meter, so I guess you could tell if your supply was working or not. And, oh, there's something down in here, taped over. Some SMD components. Kind of, oh, well, there's several components down there. There's a thumb drive in here. Fuse. It's going to be a 0.1 ohm resistor, your fusible resistor. What's on there? I have to check that out. I don't know what's on there. Interesting. Okay. Let's see if I remember how to open one of these things. These are a piece of cake compared to the Slims. I think I've got some more pry tools coming because I have just about used these up. They're getting to the point where they just kind of flex sometimes. Come on. Come on now. They don't act like they've ever been opened. No roaches, no explosions, no marks left in the cases. I did not plug this in. I'm assuming it doesn't work. I doubt he would send me a working supply. These are some pretty boards, though. These original DRs, just like emerald green color. And they're the only one that I've seen that they're double-sided boards. You don't see a ton of jumpers everywhere because they use double-sided traces. But I think it's the only one they did that on, though. So, let's see if we can do some quick diode checks on this DAP053. Where's pin 1? I see it. I see it. Yeah, I'm trying to make sure I didn't have a big reflection on my meter there. Let me find that negative terminal. Well, I will try to discharge it, but I don't think there's anything there because, like I said, hasn't been plugged in a long time. Nothing. I'm not sure if you can see that. There's nothing there. Trying to make sure this is all in the picture. Okay. We're going to check this DAP053 pin 1. I think that's pin 1 there. Okay, pin 1 is shorted. Pin 2 is shorted. 3 is good. 4 is ground. 5 is good. 6, 7, this is no connection. 7 is one of the programming pins that they, if you get, you know, certain, if you get the development versions of these chips, 7 and I think it's 11 are data lines. But you can also program the non-programmable ones on other pins, which is something I'm going to try to do. That's good on, that was 8, wasn't it? I lost count. 9, that's good. I don't know why I'm still checking pins. Well, just curious, I guess. 13, 14, 15, 16. I mean, it's got 2 shorted pins. How many pins do you need shorted? 1 and 2. And 1 and 2 are the pins, if I'm remembering correctly. One moment. Let me slide over here. 1 and 2. Yeah, 1 and 2. 2 is your boost sense line. If you look up here, 395 volts after the boost, after the PFC coil and this diode for the PFC. Roughly 400 volts through a couple of 7.5 megohm resistors, a 750K, which they left that out on later versions. They left that resistor out for some reason, the 750K. And we go through here, a Zener, 100K to ground, a little capacitance to filter it a little bit, into pin 2. And a lot of times, and this may be in our case, we'll find out, you see pin 2 also goes down to a MOSFET. And what this is a shutdown circuit. One of the ways you can disable this chip is to pull that sense, that boost sense to ground, and it immediately shuts down. And that's what they're doing. That's the this is controlled from the cold side of the board over there. So that's why that's right. But a lot of times, if this is popped, it may pop that MOSFET down there also. And 1, look at pin 1 right here. Pin 1 connected over here back to the AC line to a couple of large 10 megohm resistors. And it's on both sides because, you know, in this country it'd be 120 volts. Yeah, you would have a line and a neutral, whereas I'm sure in Europe you've got 2 line voltages, two hot legs. But here they don't know which one's going to be hot, which one's going to be neutral, because it's not a polarized plug going into the back of the power supply. So anyway, but it's a sample for timing purposes, I imagine, also for brownout purposes. It's a sample of the AC voltage going on pin 1. So you can see how that's, if you're getting some spikes on the AC line, it doesn't go, but it's going through some resistors. So not straight in, but it's likely to get popped if there's a good lightning strike. Oh, the parts of the programming, they don't need programming to work. The TEA2016. However, let me find, I've done some testing, and you don't seem to get quite as much current with the 2016. I'm not sure if it varies. I need to do some testing, see if it varies between the different models, the DR, the ER, the FR. They would work, yes, but would get unstable. I want to say it was up around 20-something amps. So, let me turn that off a second. I'm going to do some experimenting. This is a programming kit from NXP for programming TEA2016s. I want to see if I can do some playing around with it. And I've tried reading the contents of a DAP053. It's locked. You can't read it. But I can tweak a 2016 to see if I can make it behave more like the DAP053. because that's what the DAP053 is. It's a programmed TEA 2016 with the programming locked. You can't read it. I can reset it and make it go back to defaults, but you can't read it. But that's what this is. This is a USB connection and their software, proprietary software. Go do some experiments when I get some time. Anyway, kind of neat, I thought. Something to play with if I get bored, I guess. All right. So we got a bad 2016. I mean, yeah, well, DAP053, same thing. Is that all that it got, though? Let me find my parts. I do have them. I've used quite a few of these original DAP053s. I think I ordered 20 of them from, I think I got these from Cason Parts. It's been a little while ago, but I think that's where I got them. They had them, seem to have had them first. You can get them on AliExpress now, though, but why am I struggling to get that open? All right. Let's see. See if we can. I can switch to a full. I guess I'm being lazy. I set up this scene that has everything in it, so I didn't have to swap back and forth. I apologize for being, I could say, creative or just lazy. But because like any amateur streamer, I'll forget to switch. I will forget. Let me turn this heat down to 350. Maybe that won't. These boards will popcorn on you. They will popcorn. If you just lay the heat down there and don't move it around, they will. So I try to keep the heat moving and try not to go above 350. I'm just watching for those, some of those legs to get molten. Come on. Oh, I pulled up a trace. Wasn't too careful, was I? What I need to do is just add leaded solder. Lower that melting point. Which is what I'm going to do now before I put this other chip on. Okay, do I need to switch to the full microscope view? What do you think? What do you guys think? Tell me. No, this is not the unstable one. It's over here to the side, though. And I have swapped out a lot of parts on it. Can you see okay with this kind of a setup? It was kind of an experiment. When I added the face cam, I said, well, thought I would give this a try. Probably going to have to get rid of some of that glue. We'll see. Come on now. These legs always look a little bit tarnished. It's a brand new chip. But even the TEA 2016s, they have that same tarnished look to them. And they kind of just don't want to take solder. So I have to touch them up. Oops. There we go. I am thinking about trying to do a laptop. I meant to ask JFix is here. What's a good laptop to start off with? I've done MacBooks. What's a good PC laptop though? What's a repairable one? Oh, some might prefer a bigger view. I understand. All right. Well, I've already. Well, I'll switch next time. I didn't read. I must admit, I didn't think about people on their phones. I did not consider that. I'm looking at a big monitor, and I guess sometimes you think everybody else is too. I'll have to clean this up a little bit better. Oh, I have to heat this flux up too. But I'm not going to bother cleaning it up a whole lot yet until we see it work. I'm assuming that short on 1 and 2 will be gone now. Yep. Yep. All right, I think this is going to try to run now, but it may start and shut down. Why is that's a little bit low? 0.47. This is looking pretty good now. I don't see anything burned. This should try to run now. Actually, it may shut down on us, but let's see. I've got my load fired off here. What are we set on? 5 amps. Go ahead and turn that on. Negative. Positive. Where's my AC cord? Let me get my meter in here for reading this boost voltage. The one was unstable. I still hadn't fixed it. I put a DAP 053 in there instead, and now it's reasonably a little bit more stable, but it's still not right. You get up in the 20-something amp range, 24, I think it is. I can't remember. That boost voltage just gets to wandering around. It is always near. It's sitting here staring at me off at the side. That one, and this is the one I was comparing it to actually, and I've swapped a lot of parts out between them. Swapped a lot of parts out, a lot of those little capacitors, anything in the feedback circuit, and it's just not stable. Getting a call, it's a spam risk. No, thank you. All right. Negative, positive, we're set. Just 5 amps. Watching our boost voltage. All right, I'm going to turn it on. Start bringing it up. And try to keep my arm out of the way somehow. Yeah, she started right up. She started right up, no problem. 393.4, putting out 12 volts. Well, that was easy. These filter capacitors are not swollen. That's good. So this one just basically it took a strike on the line voltage. It took a surge, and like I said, into that pin 1 particularly. Pin 1 is the one sampling the AC input line voltage. Of course, it's not hooked to it directly. Like I said, it's through several large resistors, but still, you get a good spike. It's just going to pop it. So, all right, I need to. I'm going to plug it into the my power strip back here. Like I said, I think I mentioned before, I can only go up to about 2 amps on this variable supply because it's fused at 2 amps. It's a slow blow fuse, but it is fused. And that's nowhere near enough to push this power supply at 31 amps. So I'll plug it into the outlet back there. And we will run it on up, see if it stays stable. 10 amps, 11. 25 amps, that's pretty rock solid. 31 amps, it never flinched. Let me run it down a second and I will check the, like I said, the voltage is going to show low here because of the loss across these leads. The leads I have going into that load they're not huge. They are a 14 gauge wire, but they're very flexible. So I just use, if I'm really that concerned about the output voltage, and this is going to be, probably won't go below like 11.9 at maximum current, but I'll run it back up and we'll check. 20 amps, looking great. Oops, I went to 32 amps. It'll work at 32 amps also, you notice. 32 amps. 31 amps is what it's rated at though, 11.978. That is a good solid supply. Okay. All right, one down. Unplug it. I should probably bleed that voltage off before I handle it, and I will. It's not really in the picture, is it? There you go. And we're down to like 3 volts. And you'll see it charge back up. That's just the nature of these large filter caps. What do I do with the covers? Where did I put the covers? Oh, here they are. What are we talking about over here? Yeah, that one's stable. He sent me 6 power supplies. We'll see. Put it back together. Anybody else streaming today? Anybody else? I caught Andy this morning. I need to mark this one. Need to have me some stickers. I usually end up using Post-it notes taped to these things, but could just print my own stickers, I guess. It's on the to-do list. It's on the to-do list. I'm going to go ahead and put a note on it, though, because I'll lay it in a pile somewhere and I won't know. This is a 400 DR ADP 400 DR. Okay. This is kind of a note that I like to stick on them. So that when I grab it out of a box later on, I'll know what it is. Now, what did I do with my tape? Tape, tape, tape. Oh, struggle of getting tape started. Come on. And I put the model on there so I can read that quickly, because otherwise I gotta get the light just right to see this over here. All righty. Put that out of the way. So far, no. That's the only issue is, that was the first one we looked at, though. We had a bad DAP 053, shorted on pins 1 and 2. Into the garbage it goes. This is a FR. I'm getting another call. Spam risk. Gotta love those. I've got to turn on my ceiling fan. Give me a moment. It's warm in here. I think I have, like I said, that PS5 I worked on this morning is over here running. Can you see it over there? I don't know if I can. Yeah, there it is over there running. But that's the only one I have right now. I have another one coming in today. That one was a relatively easy fix. It's a shorted capacitor. I'm having a hard time finding consoles to buy. I'm sure some of you have noticed that there's the prices have gotten to be, the prices on broken consoles have gotten stupid. On PS5s anyway. Gotten to be a bit ridiculous. Maybe it's because of the time of year. But yeah, I only have 3 coming, and that was one of them over there. So I'm happy to have these supplies to at least work on. maybe after the holiday season, prices will normalize a little, get to be a little more reasonable. Yeah, this is how we bend the pry tools. There we go. So far, no roaches. I appreciate that. Now these came from Chip. I think it's in Florida, in the United States. And Florida is known for having lots of roaches. Yeah, some bots. I was watching a PS5 Slim I was wanting to bid on yesterday, and the price went stupid high. And I remember thinking that why would anybody do that? And then, anyway, so I forgot about it. And then all of a sudden I got a notification it had been relisted, which means somebody ran the price up and then didn't buy it. That's exactly what that means. They ran that price up to, I think it was $300 or something like that. All right. Another, this is an FR. This is an FR. And they're all very similar. All these supplies are pretty similar. Not identical, though. I should probably check this thing, discharge it before I do anything. Just as a good example, don't stick your fingers in these things. There we go. There's nothing there. Nothing at all. Okay. Where's pin 1? Well, same place it's always in. I just have trouble seeing it without the microscope. Pin 1. No, we're not shorted on pin 1 this time. 2, 3, 4 is ground. 5, 6. I'm sorry, I'm getting off on my count. That's 6. That's 7, which is no connection. That's 8, 9, 10. This is all looking good. 11, 12 is no connection. 13, 14, 15. We made it. We made it so far in. Pin 16 is shorted to ground. What is pin 16? And this is an FR. One moment. Let me find the schematic to an FR. And can I pick that? OBS is just weird about some things sometimes. Okay. Okay. FR. What's on pin 16? Why am I trying to zoom there? 16. I don't recall off the top of my head. Oh, that's where the feedback voltage comes from the cold side. Huh. Never seen that shorted. So is the short R DAP053? Yeah, probably. And there's a Zener here, but yeah, if you've got to play the odds, it's probably the DAP053. So we'll take it out, and we'll see if that short goes away. I bet it does. That's the only pen that was shorter was pin 16. Oh, yep. Pin 16, which is where the feedback is. Ouch. My probes are sharp there. Okay. This time, I'll switch to the full microscope view, I think. Well, let's see. Microscope, microscope, microscope. There we go. This time, though, I am going to add some leaded solder. We're going to be a little kinder and gentler. We shall try to be. There we go. What do I do with my solder? Oh. Try to prevent me from lifting a pad like I did last time. Get in a hurry, it'll happen. Only seems to happen to me when I'm recording though, or live streaming. I guess it makes me nervous. All right, I need to remember to check. I'm going to take it off. And I'll do a quick check on 16. All right, you ready to come off of there? If they are glued down, it's part of the manufacturing process before they go through their reflow oven. They glue the things down. Let me get these pads and we'll get rid of any shorts. Now let me check right quick, like. I'm in continuity mode. 16, right here. That short's gone now. Okay. So once again, probably just a bad DAP 053. I am down to my last 10 DAP 053s. Probably time to order some more. Or just use the 2016. I've got a bunch of those. I've got plenty of those. Oh, come back here. It's a little bit high. Leave it alone and touch it up some. And I just realized I did not finish cleaning up that board in that last one. I need to take it back apart and clean the flux out from under that chip. Just hit me that, wait, I got in a hurry and moved on too quick. It's right behind me, it won't go far. I'll get it cleaned up. I don't like to leave flux on the board at all. Don't like to anyway. So these end pads really have a lot of solder to them. Maybe we can get rid of some of that. Now, did I put the chip on the right way? I have put it on backwards before. Yes, I would say that is the correct way. And I need to get rid of, I see a solder ball sitting on this Zener right here that does not need to wander around and short something. All right. All right. Let's see if we can switch back. Nope, that's not it. It's not it. It's not it. I've lost it. I'll never get it back again. Nope. I've lost that view. Where did it go? I don't know. Professional streamer. Are they all going to be this simple? I hope not. I wasn't trying to make them simple. I just opened the box. I just opened the box. This is what I was sent. There's that. Make sure I get this polarity right. All right, can you see everything? What am I? I'm set on 5 amps. Okay. Again, get my arm out of the way here. Somewhere around, what is it, around 80 volts AC. She should start trying to kick over. We're not starting. We are not starting. We should have long ago started. Okay. We are getting our rectified line voltage, you can see there. Let me think. I need to lay it over to check the other side, which it gets to be kind of dangerous. Because I'm curious, can I do this? Yeah. I'm curious if the line voltage, if the supply voltage is on that DEP053, which I believe is pin 13. I am curious. Those caps are still charged, so I'm not going to touch this thing if I can help it. Pin 13. There's actually a capacitor I can get on here a little easier. 1.9. All right, I'm going to turn it back on. Seven volts. That's not normal. That should be closer to like 16, 17. Did we lose a Zener? That voltage, let me see. Let's look at it. the startup voltage comes internal, from an internal current source. No, it's not that same supply. Let me see if I can find that view again I had. Okay. I'm trying to find the view I just had with all the different layers on it that I needed. And somehow OBS has eaten it. Yeah, I was just there. I was just there. Nope, that's the schematic for. What I'm trying to go over with you is. Oh, this just kills me. You're killing me. Professional. So professional. I don't know where it went. I just switched off of it, came back, and the scene's gone. Okay. What were we talking about? What were we doing? Where'd it go? Oh, we were talking about where the startup voltage comes from. It comes internally from, what is it, pin, okay, gonna make me bring up the data sheet. Okay. Let's look at the data sheet. So if I click that, and then I click this, and then I click the other thing. Eight. Internal high voltage startup source, also used for X capacitor discharge, valley detection, PFC over voltage detection, connected to the PFC drain voltage. So pin 8 is where it's coming from internally, because there's 170 volts, you know, just rectified DC there. You got like 160, 170 volts DC. So where does pin 8 come from? Well, like it says, it's from, through a 1K resistor. It comes from the PFC circuit. There's the drain of the PFC transistor right there. So there's a R79. Is R79 good? Is it open? I don't know. This thing is still live right now. Still has power on it. Where is it? I think I see that. I think I see that resistor. Yeah, I see it. Let me check on one side, then the other. $159 volts, and on the other side, 153. So yeah, I think it's getting there. But on pin 13. We're ending up with 7 volts. Make sure I'm on the right thing here. 8, 9, 10, 11, 12, 13. Yeah, 6.9 volts. I'll switch to the microscope view. Yeah, 9, 10, 11, 12, 13. I was checking on this capacitor right here. Just as it's more convenient, less likely to slip between the pins. Just tap on that right there. I'm getting like 7 volts. There's a Zener across it. That voltage does go... Let's check. Let me turn this off. Let's discharge this. Curious what the resistance is on that pin to ground. May have to open up another one to compare it to. Actually, I've got one open over there, I think. Let's discharge this to a little friendlier voltage. Should be down to like 3 volts at that point. We can short it if we need to at that point to bleed it on off. It won't hurt anything. Okay. Pin 13 to ground. 13 now. Here's my ground. Pin 13. In the megohms. We must have some DC voltage there. Yeah, 1.4 and bleeding down. Doesn't sound like there's a short there. It would have bled that off a lot quicker. So, it's going to be one of those. Let me get set up. I need a clip lead to get my ground. What did I do with it? Where'd it go? I need a ground clip to give me a free hand. Oh, there it is. No, that's not it. Oh, it's right here in front of me. All right. I'm curious if that voltage is coming up and then going away at some point. That's what I'm curious about. I want to try to watch it as I bring the voltage up. That's not hooked to anything right now. Oh, it's not on the screen, is it? So, there's our raw rectified voltage, 19 volts. What do we have on pin 13 at that point? 5.2. If I keep bringing it up, 6, 7 volts, 7.5. Doesn't want to go any higher than that. We're at 56 there. What is going on here? That's too low for this chip to start, as best I can recall. I have to look at the data sheet to get the exact value, but Yeah, she comes right up when you get to about 7 volts. And that's it. Of course, there are some capacitors involved. There's a Zener involved. Because it was pin 8, wasn't it? We're at 48 volts coming in there. I can keep turning it up. Plenty of voltage coming in to get us what we need to start. Plenty of voltage coming in. There's a Zener. Let's look at it. Where was I? Where was the schematic? So, getting plenty of voltages on 8. 13 is right here. 1 microfarad capacitor. There's a Zener. Another capacitor there. And this is the circuit that takes over. When it actually starts running, this is the secondary supply that powers it. A little winding off the main output transformer. You rectify it, you filter it, you go through a little, I'm not sure what they call this regulator. It doesn't try to hard regulate it. This voltage will vary like crazy. Because this voltage over here varies like crazy. As the harder this circuit drives to drive more current out, the more voltage gets developed here. And they don't try to regulate it real tight. They let it wander around. I guess maybe it limits it in some way. But anyway, where is that data sheet? One moment here. I'm just curious about drain PFC. Yeah. There's an idea of high voltage startup. But I want to see what the voltage is supposed to be. I'm thinking it's like 13. It's hidden way down here in the table of endless numbers. No. I guess I should remember this number. But I don't. Okay. What do they call it? V-start or something? Sense mains. No. Supply. Start voltage. Typical 19 volts. Minimum 18.2. Okay. So that's what it wants to be able to start. First, using the oscilloscope, it's dangerous. I can use it on some things when I'm plugged into my isolation transformer. If you're not isolated, see, I can only use it up to like maybe 10 amps coming out of the supply. Beyond that, I'll blow the fuse in my isolation transformer and have to plug it straight into the outlet. And I've done this before. If you plug it in straight into the outlet and I did it not thinking. I knew better. I tripped the breaker because you can end up shorting out the AC line, which is exactly what I did. And as soon as I did it, I knew what I had done. So anyway, I do have a portable oscilloscope coming though. I've got one of those coming, so I can use that. So you got to be careful. But what I probably one of these days, I'll get me a larger isolation transformer. But I don't have one right now. So it's looking for, looks like 18, 19 volts to be able to start. So that's why we're sitting there doing nothing, because the voltage never gets that high. Okay, let me switch back. I'm not sure what's going on, because unless this Zener has broken down, that's always a possibility. But see, there's not like a hard short on this line, because that DC voltage there, I was checking earlier, it was slowly bleeding off. He wasn't instantly going to zero, it was just kind of slowly bleeding off. Yep, ground probe on, yep, that's, if you remember back in the days of the, well, of the hot chassis TVs, yeah, you could burn up the ground of an oscilloscope probe in a hurry. Not that I would know anything about that, but I heard rumors it could happen. All right, I need to lift. I'll lift that Zener, and what I could do then is trying to decide if I want to try to supply that voltage from an external supply, or just lift the Zener and see what happens. That's probably, I'll just lift the Zener. After I discharge this capacitor, I'll lift the Zener, and we'll ease the voltage up coming in, and we should see if it goes beyond 7 volts this time. I don't recall having to replace that Zener. I do have some of those, but it's got a feeling that's not the problem. Alrighty, we're discharged. I'm going to turn that off. Oh, I'm sorry. I got to switch the scene, don't I? It would be very nice if it was just the Zener. See, this is I lost something here. And I don't know how I did it. Okay, let's check that one. It would be nice if it was that convenient Zener right there. Let's get to it. Of course, there is a capacitor right there, but this is one that may not have failed because of lightning. It could have just failed because of weak components. I'm going to go ahead and tin the legs on that capacitor there also, just in case. Just in case you have to lift it also. But there's no short there, not a hard short or anything. Trying to make sure that. This Zener is like, I want to say 30-something volts. Set that to the side. All right, let's just see now. Let's see what that voltage will go up to now. Okay. We get back on pin 13 on this capacitor right here. bring it up slowly. Looking very familiar. We're stuck at 7.4 volts. Not going to be the Zener. Yeah, she's not coming up any higher. Yeah, we've got 67 volts DC there. This is kind of starting to be familiar to me. I've seen this one time before, I think. The internal supply that is trying to do this startup is extremely current limited, intentionally. So if there's anything loading it down, it won't get to the point where it starts. Let's make sure you can see. Yeah, we made it up to 60 or 70 volts there before I shut it off. Actually, it's still, I need to turn that switch off. So, is it the capacitor? There's the capacitor. What about there's also the transistor over here. Now, I think that's the one. This transistor is the one that powers the circuit once you're up and running. Once the oscillator starts running, it's driving that output transformer. This is the one that would supply the current then. But I suppose it could also be the one loading it down right now. What if we just check around this thing? This is an NPN transistor. That looks good. That looks good. 1 volt across it though. I believe this is the base. I think this is base collector. I think this is base emitter. I'm not sure if this, I'm getting in diode mode, I'm getting a 1 volt reading across that thing. What is it? What do we have in resistance mode there? From collector to emitter. That's like 900 k ohms. Okay. I don't think this capacitor is our problem. I really don't. I keep looking to see if I put that chip in backwards, but no, there's pin 1, there's pin 1. And the diode reading on that supply pin, pin 13, is nothing, out of ordinary, I don't believe. Pin 13 right here, 0.7. What do we normally have there on 13? 692. Yep, 6.692. That's pretty close to 7/10. So, now if I could remove that though. I'll remove it, and we'll just see if that voltage will climb beyond. I might as well leave that meter there. I'm going to need it. See if it'll climb beyond that 7 volts. Maybe we're barking up the wrong tree entirely. I don't know. I'm going to set that to the side, along with that Zener. Okay. Get this out of the way. I'm thinking it's still going to stick at 7 volts. That's what I'm thinking. Yep. 7.5. Even though on pin 8, there's 90 volts there. More than enough. More than enough. Should be more than enough to make that thing work. But we're definitely not getting high enough to start. So what is it? Oh, it's a different camera setup we're playing with. It's an experiment. So 8 drain PFC. Yeah, we're getting like 90 volts there. We have lifted, this is pin 13, lifted C79. We have lifted ZD38. We have not lifted this one. It's an electrolytic capacitor. Let's see, it does go on off down here, doesn't it? To a opto isolator. What would happen? No, that goes to the, I wouldn't think so. Don't think so. I mean, how likely is it that this opto isolator has shorted across? Not very likely. And if it did, all you've done is short into the gate of a MOSFET, not to ground. You got another Zener here, but you gotta look, that's 22K right there. 22K to ground. What if, what if we lifted J33 here? What if we lifted this jumper and isolated all this circuit over here and see what it does? Audio's cutting in and out? Is it cutting in and out for anybody else? Do we lose sound? I hope not. How is it now? Maybe this is the trouble I had earlier. How's the audio? Audio's fine? Huh. Oh, hey, Roy. Well, bye, Yeti. Go get that work done. Thanks for coming by, though. I'll lift this J33, which, you know, I think that should come up without that little bit of capacitance. It probably needs that capacitance for normal running, but okay, J33. We're going to lift J33. Is it that one? Is it that one? We're going to lift J33, and we're going to discharge this capacitor first, though, aren't we? We're going to discharge this filter cap before we stick our hands in here, because we've got about 90 volts there. Don't get bit. It works in electronics and in the zombie apocalypse. Don't get bit. All right, where is that jumper? Is it? It may just be not a physical jumper. Maybe a 0 ohm jumper. What did I say it was? J33. J33. J32, J29, J26. I guess I could just follow the stupid thing back. Right through here, right through here, right through there. J33. I feel like I'm missing something. Come on, there you go. No, let's see if we can just park you. Not enough solder on that end. Let me flip it around. And it went into another reality. Nope, it's back. It's back. I want to stick that right there. Come on. Stay right there. All right, so we've isolated it from the rest of that circuit. What does it do now? Get on that pin 13, or on where the capacitor used to be, and see if we can bring it up slowly. No, we're still going to 7.5 and stopping. Now, why does this seem familiar? Because that comes from pin 8, drain PFC. And I'm assuming I can get this all the way up to there. That's 150 volts. 156 on one side of that 1K resistor. 151 on the other side. That's plenty. Do we have a bad chip? It's fresh out of the sleeve. I wouldn't think it's a bad chip. Let me discharge this again. What is this? Oh, my package was delivered. So there's a PS5 sitting on my porch. Joy. Resistance to ground on pin 13. With everything's removed now, it's isolated. Man, we're in the K ohms. So what gives? That voltage is internally routed. Is there any other weird readings? I don't remember any other weird readings. We changed the chip out. And it doesn't go anyplace else. 1, 2, 3, 4 is ground, 5, 6, 7, 8, 9, 10. If I go back to 9 now, it'll read normal. See? Something gets latched up internal. Now to read normal. All right, that's 10, 11, 12 is no connection. 13, it looks normal. 14, 15, 16. It looks fine. I don't see anything. And I'm going to assume this resistor, well, I won't assume, I'll check it. This 1K resistor, which is what's supplying that connection to that drain PFC, 995 ohms. Pretty good. I am, all right, Terry, what I'm going to do, I'll just drop a 2016 in there. Because something is acting weird here. I have plenty of 2016s. I can't think of what else would cause this. Basically, it acts like it's loading down the startup voltage. But we've removed everything externally connected to it. Take that off. Where's pin 1? For once in my life, I picked up a chip and it left. So I'm going to say I picked up a chip and it was it was oriented the right way when I picked it up. And then it shot off into the 9th dimension. And from now on, when I pick it up, it'll be turned the wrong way. Come on. It is turned the right way. There's a big pin 1 mark in the corner there. Do need to touch these pins up a little. So again, there's the tarnish on those pins. And there's just a little hesitant to take solder. They will, though, with some flux, a little bit of heat. Okay, that's turned right. All right. Can we get above 7 volts with this one? What do we think? All the way down, okay. Let's get it right there. Start easing it up. Same thing. The exact same thing. That is weird. $7 volts and no higher. $7 volts and we shut down. And according to the data sheet, it wants 18. My leads are all tangled. Okay, we got another good one here. Something, I'm trying to remember something. No, I don't think I missed a trace. I really don't. I'm missing something about how this chip works, though. Something about how the startup circuit works. I think that's what I'm missing is 19 volts, typical. V start. Now, is this a characteristics? That's not the maximum. That's the startup voltage, it says. Low voltage on pins, 12 volts. Under voltage protection, 10 volts. So basically, if you get it started and you get down to 10 volts, it's gonna shut down. Output voltage. There's a whole section of this data sheet. It's a pretty good data sheet on nothing but the startup circuitry. Internally, a high voltage current source. Is located between the drain PFC and the supply IC pin. And that voltage is there through a 1K ohm resistor that measures 995 ohms. Is there anything else that would prevent it from doing its thing? High voltage supply pin for startup. General supply, yeah. Flows on high side driver. Got that. I think I've seen this once before, but I can't remember what it was. Although also I don't remember it needing 19 volts to start. I thought it would start with like 12 or 13 or something is what I was thinking. It acts like it's being loaded down, but there doesn't seem to be anything there to load it down. Nothing over here looks damaged. This is on your AC input. Let me see what my phone is making noises back here. Goes to there. We lifted that jumper. could do is give this thing 19 volts and see if it kicks over. Because I'm just kind of curious at this point. Pin 8. Yeah. 1,000 ohm resistor. I'm trying to think of anything else that would prevent it from starting up. Let me make sure. Does it need that capacitor on there? I don't think so. Let me check this capacitor that we took off earlier. Yeah. Well, if I can get a good connection. 9. 946 nanofarads, which would be just under 1 microfarad. Yeah, that looks good. I don't think I can check that Zener, but the Zener is just there as a safety thing. It wouldn't keep it. If it was shorted, it would keep it from running, but it wouldn't keep it from running otherwise. What am I missing here? Am I in diode mode? I was just checking the diodes in this bridge. Why did I read a short there? Why do I read a short there? Between these middle pins. Is there anything connected? Oh. Never mind. I know what the short is. I know what the short is. I know what the short is there. That's your AC input. Right there. And right now I'm plugged into my isolation transformer. No more short. Unplug it from the isolation transformer, even though it's turned off. It's still the winding, it's still connected to the output winding of it, so yeah. Well, that explains that. Man, looks like good diodes to me. Okay. Of course, if there was a bad diode, it should have blown the fuse. or the current would have gone through the roof. What would prevent this thing? I mean, it's not like there's any major leakage there or anything. Look at that. 470 k ohms to ground on pin 13. Extra bubble of solder there. Get out of there. Nope. Yeah, 100 k ohms there is perfect. I have to get another supply out and make some comparisons. I'm trying to figure out if some other external circuit could cause that. That all looks perfect. Absolutely perfect on those opto isolators. This is part of the current sense feedback. Shouldn't be an issue at this point. We're not even running. There's nothing to sense. I'm assuming, let me check, we do have a good ground on pin 4. Oh yeah. Yeah, that's a 10 ohm resistor. Okay. Let's see. What are we talking about? Or we're talking about other devices. All right. What if I feed 19 volts into this? If I feed it from external supply, it doesn't matter. I've got the onboard one disconnected. Wouldn't matter at all. Let me do that. Let me get a lead to solder. Do I have one laying here? Yeah. A cut resistor lead or whatever. We will put 18, 19 volts into that chip. I'm curious if it starts up and runs or if it just sits there. Get my bench supply set up. I don't need 2 amps of current. I don't even need 100 milliamps of current for this. I'll set it for 200 milliamps. $19 volts, 200 milliamps. Ground. And connect you there. I need to be able to meter the output. There. Let me make sure. There we go. Okay. Get ready to put some AC voltage in. Thinking, just thinking. Ground, we have that. Let's enable the 19 volts. She's drawing 20 milliamps. Give it some AC voltage in. No. Turn this off. Turn it back on. Now she's trying to run. Putting out 1.5 volts. She's trying to run. Drawing 15 volts, 15 milliamps off that supply. So you can't see it now. Let's reposition that. No, you can't really see it. We're drawing 15 milliamps off this external 19 volt supply that I'm feeding. It's running, but it's not happy. It's not happy at all. Yeah, 1.5 volts out. What if I take that load off of it? It dies away. Load back on, she shut down. We got some weirdness going on. I'm going to reset that supply, give it back 19 volts, and we run. So she runs. She's not right though. What's our PFC boost voltage at this point? It's a little low too. It's varying around a little, 390, 395. A little unhappy. We're running. If I give this 20 volts, she's fine. Didn't change anything. Get the feeling it's like trying to shut down. Very, very strange behavior. The MOSFETs aren't shorted or anything like that. Could be something obvious here. PFC is running. The LLC is running. Not producing the proper voltage though. Is that because our feedback's not right? This one, of course, has the DMP014 on this side. I do have some of those. What time is it? I'll see what time it was. So basically she runs, but she doesn't want to run. What are we generating? This is the supply that I've got disconnected right there. Well, get my leads reversed, negative 23 volts. So that's that secondary supply that would be connected into this IC if I didn't have it isolated. It's generating, no, it's 23 volts unloaded. It would drop down more like 19 or something if it was loaded probably. That looks normal. This is going to be another strange bad capacitor. I'm going to turn this off. And she should shut down, and she does. What are we talking about now? Yeah, we're still on the same. No, the supply IC seems to, well, I can't remember. It can go as low as 12 once it's running. Let's see. I'm missing something. I'm missing something obvious. Drain PFC voltage. What are the reasons that it would not start? Maximum current of the internal current source is limited to ICH supplies. Temperature? What is this? You're not going to tell me that, are you? I'm curious what the current limit is on it. Not going to tell me. Auxiliary winding. Looking for some hints here as to what would keep that voltage from going higher than it does. That startup voltage. Hits that magic 7.5 volts and just kind of goes, nope, not going to go any higher. And I don't measure any shorts on anything. There's got to be something. If I force it to run, the PFC runs, the LLC runs. It's not right, which is probably telling. It should be telling me something there. If I force it to run by giving it 19 volts, it still doesn't run right. It still hesitating. Output voltage startup. No, 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 that's output voltage startup. Does it do weird things if it can't sense the mains? And then there is the temperature sensor. There is the temperature sensor. It has an odd temperature sensor circuit. The same, where is that? The same pin, where is it? Yeah, right here. The same pin that it senses the AC voltage on, right here, it goes to pin 1. It also, every so many cycles of the AC line, it will check this. It will like supply a current out of here and check this temperature sensor, see if the unit's hot. Kind of strange. That's how they get multiple uses out of single pins by doing things like that. But it's like every 3 or 4 cycles, it'll do a check of the temperature sensor. Very odd. Would that keep it from trying to start? I don't know. I think you should try to start and then shut down is what I think. But I've removed everything from pin 13. I've removed everything from pin 13. There is nothing. That's the supply pin. There is nothing left. What's supposed to happen is you get 170 volts here on pin 8 connected back to the drain of the PFC transistor. And internally, a current source should supply current to this, a certain amount, to pin 13. And when that capacitor charges up, of course, then again, there's no capacitor there. Is that the problem? I removed the capacitor. Let me put that capacitor. I don't think that's the issue, though. It's a current source. Let me discharge this thing. Yeah, it was over 300 volts. That hurts. Over here. What if I put this capacitor back in there? going to stick it. Oops. I'm just going to go hunting for it now. I need to turn this board. I'm just tacking it down for now. And at some point I need to leave it alone. All right, it's just stuck it on there. But I'm still isolated. I'm going to take that off. We're just doing an experiment here. Just a little experiment. Get set up where I can monitor that voltage again. Now that I put the capacitor back in there. Unhook my supply. Let's see. Yeah, dial that down. Will it come up? Now the capacitor is back in there, but we're still isolated from the rest of the circuit. That's what I wanted to see. I don't think so. 7.6. That's all she'll do. This seems familiar. I think I've seen it one other time, and I cannot remember what it was. Cannot remember. Okay, it's starting to get to me now. No PFC. No other PFC. It won't run unless I give it 19 volts. Let's see. This one here. Properties. What have I done? I've got to fix something here. Going in circles. What is that maximum current? Twelve volts is considered low. What's the current? What's the maximum current? $865 microamps? Well, it was drawing like 20 milliamps. charge current, oh there we go, charge current on pin supply IC with 30 volts on the PFC drain circuit. Typical 8.5 milliamps. Maximum 7. Very, very strange. What's that? Yeah, that was a different issue though. We're not even starting. Yeah, that was. You talking about the one you worked on, Andy? Yeah, that was the case though, where your IC was running, but it was being told to shut down. It was being held down. This one's not running. It never gets enough voltage to run unless I feed 19 volts in there. If I force 19 volts in, it tries to run. Doesn't do a very good job of it, which is probably a clue as to what's going on. That's what we like to call a clue. Even if I make it run, it's not right. V-start. Of course, they don't want to tell you what that number is. I think it's. According to that, what we saw earlier was 19 volts, which seems higher than it should be. I know the chip it'll take up like 30 volts on its supply. V-start, supply IC. Start voltage on pin, supply IC. 19 volts typical. Yep, 19, it should, but we don't get there. Yeah, supply voltage has to be 19 volts on that pin. But, like what we were talking about earlier, in the beginning, when there's nothing running, that voltage has to come from internally from the drain circuit. Where do they show that? Yeah, this right here, startup and supply. Pin 8 is drain PFC. There's like a 1K ohm resistor. It's not hard. It's not tied straight to 400 volts. No, it wouldn't live long if it did. But it's still a 1,000 ohm resistor. And in here there is a current source. X-cap discharge, supply IC. Yeah, this right here is supposed to supply current to this and charge up this capacitor on pin 13 to the point where it can start. And then the secondary voltage takes over. Hello. I don't think it's trying anything. I know what you mean though. Is my meter too slow? Meter's pretty fast. But if y'all want to see it before I give up for the evening, we'll put a scope on it and see what happens. Let's see here. As soon as I can find the appropriate layers, just move some stuff around. Scope. Can we see the scope? Is it going to show up well enough? And I am plugged into the isolation transformer. Otherwise, you do not want to do this. What am I set on? Let's do some DC coupling. Limited bandwidth. 10 times. I don't really need the 10X Pro, but I'll leave it in net mode. Let's get some ground. Okay. All right, are we zeroed out pretty well? Let's see. Yeah, 0. What are we on per division? 5 volts per division. Nah. I got a feeling 2 volts per division is going to do it for us. I don't think we're going to get over 7 volts, not even momentarily. All right. See it starting up. I stopped it. I've only got like just a few volts AC in. Oops, and then I knocked my entire camera out of the way. Did I break something? Let's hope not. So I will ease it on up though. And it drops down. That was interesting. I've turned it all the way back down to 0 on the AC input. Bring it back up. What does that look like? Looks like some little capacitor charge and discharge action going on there. And we're going off the screen. Let's go back to 5 volts per division. Yeah, and that's as high as we go. I'm going to back it all the way down to nothing. And I will bring it back up. The heck? My TV just unmuted over here on its own. Good of you to join in there, TV. That was weird. You just decided to unmute. Little capacitor charge discharge ripple there. But I mean, I don't see it. I don't see, it's not, definitely not going up to like, in the teens, like 17, 18 volts and then coming back down suddenly. It's not doing that. I'll bring it back up. Yeah. There's 30 volts AC in, which is like the minimum it needs, I think. She just stops. She just stops. Okay. Just looking at some messages on my phone. Yeah, apparently something took over. One shot it. It's not trying. It's not trying. Okay. I'm getting frustrated, so I'm going to go for now, I think. Been at this 2 hours. We fixed one supply. We might have to continue this tomorrow. I think I'm still off tomorrow. We got more supplies to fix, but we got to get past this one first. But anyway, I've got to come up with something for dinner. So I thank you for joining me. And we're not going to give up on it yet. We're not going to give up on it yet. But I'm starting to get frustrated with it. So, but I do definitely thank you for all coming and joining me. I'm gonna be thinking about this all night. So don't worry, I won't give up on it. But thank you all for joining me. I'm gonna give it a rest for a while. I gotta go find something for dinner, and then I'll be back. I don't know if I won't be streaming anymore tonight. I don't think. Probably tomorrow though. Probably tomorrow we'll rejoin this issue because I've seen this before one other time, but it hasn't come back to me yet what it is. But it'll come back to me. Thanks, guys. Thanks for joining me. I do appreciate it. Bye for now. See ya.